Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 applied students who are looking for extra help as they study and prepare for the June EQAO. This is video number 1. In this series of videos, we look at questions that were asked in last June's Math EQAO. These questions are available for everyone at the following website. My suggestion is that before you watch these videos, you go to this website and look through these questions on your own. Try as many of them as you can. Then, as you watch the videos, compare my answers to yours. In that way, you can tell which questions you're successful at and which questions, and therefore which topics, you need a little more practice with. Just a reminder that on the EQAO, there are 2 types of questions: multiple choice questions and open response questions. Open response questions require you to show all your work and to be as communicative as you can be. What I'm asking that you do is, as you watch the videos, if you have any questions about the math, or if you would like to see any more questions or solutions on a particular topic, please post that information in the comments and I'll get back to you as soon as I can. Okay, let's look together now at the first question. It says the dimensions of a rectangle are in a 3 compared to 5 ratio. If the shorter side lengths are 30 centimeters, what are the lengths of the longer sides? Now, some of you may know the answer very quickly, but I do want to take the time and review the concept of ratio. It's an important concept. There aren't a lot of questions in this package that deal with ratio, so I think we should spend the time and make sure we understand ratio. And again, after this question, if you want more ratio questions, post that information in the comments. I'll find more questions and we'll take them up. Okay, so let's review. It says the dimensions of a rectangle are in a 3 to 5 ratio. Well, what do dimensions mean? Oops. For a rectangle, the 2 dimensions involved are length and width. Those are the dimensions of a rectangle. Normally, people refer to the width as the shorter side and the length as the longer. Although that's not necessarily true, let's make that the case in this question. So we're going to call the width the shorter side and the length will be the longer side. Now what we know is that the ratio of the sides is 3 compared to 5. And let's explore what that actually means. So here's how I suggest you think about and explore ratio. First of all, it's very important that when you're given a ratio, you understand clearly which dimension or which item is the first and which is the second. So obviously 3 is shorter than 5. So 3 represents the shorter side and 5 represents the longer side. And we decided that we would call them width and length. So to me, we always set up a table. Oops, you always set up a table to help you deal with ratio. So the 2 items that I'm comparing are width and length, and the ratio I know is 3 compared to 5. So what does that mean? It means that it's possible that my rectangle has a width of 3 and a length of 5, and if that were true, this would be the rectangle. But it doesn't mean it's necessarily 3 and 5. It could also be 6 and 10. And the way I know that is because if I made this side 3 centimeters longer, so a total of 6, then I must make this side 5 centimeters longer for a total of 10. Because ratio means that every 3 units that I add to this side, I must add 5 units to this side. So if I increase this side by 3, I have to increase this side by 5. So here is another potential rectangle. And here on my table, I've added 3 and I've added 5. Now maybe it's another 3 centimeters longer, which means this would be another 5 centimeters longer. So here's that potential rectangle. And here's what it would look like on the table. 3 centimeters longer, 5 centimeters longer. So 2 things you should notice. First of all, visually, you should see that there's a constant regularity to the size of this rectangle. Basically, what I have is the same rectangle, it's just getting bigger and bigger. So what we say is that I'm keeping the rectangle in proportion by keeping it at 3 compared to 5, or 6 compared to 10, or 9 compared to 15. That's keeping something in proportion. Sorry, I don't know why that keeps popping up. So obviously you don't need to draw the picture to do this. All you have to do is continue to build your table where you're adding 3 over here and therefore adding 5 over here. And you could continue to do ratio in this way until you get to your goal. And in this case, our goal is to see 30 under the shorter side. And when you see 30 here, you're going to look over here and that'll be your answer. And that's one approach that you can have to any ratio question, is build a table, keep adding and make sure the values you add are in the proper ratio. That's a perfect method, but the drawback, as you might understand, is that it might take a while to add until you get to your goal. So I want to show you another way of working with ratio. It starts off obviously the same way, making sure that you understand what the values you're comparing are. And again, in this case, we're comparing width to length. 3 is width, 5 is length. So again, here is the primary ratio that we're working with. Now, this method is faster. So what we do is instead of building values, we jump right to the value that we want. We want to see a 30 right here in the width column. And that means I just have to figure out what goes here. So whereas the other method involved addition, this method involves multiplication. I need to figure out what number do I multiply so that 3 times something gives me 30. So you may already know that answer, and that's great. But let's make sure you understand how to do it if you don't know the answer. Here's your brain. Again, this is what you're trying to think of. 3 times something is 30, and you need to fill in this blank. If you don't know what that number is, the method goes like this. If you're looking for a number that multiplies, you can always do division to tell you what it is. We know that divide and multiply are partners in the math world, so if you're looking for a multiplication number, just do division. 30 divided by 3 gives me 10. So 10 is the number. 3 times 10 is 30, and that's what I usually call the multiplication factor. 3 times 10 is 30. And if you know that 3 times 10 is 30, then over here you have to do times 10. If you know the multiplication factor on the left, it's the same factor on the right. So 5 times 10 is 50. And that tells me that if the shorter side is 30 centimeters, the longer side is 50. So again, there's 2 methods for working with ratio. Whichever method you like best, they're both great. Okay, so that's ratio. Let's go on to the next question. It says the table below shows information about renting movies from 4 different stores. Which store offers the lowest cost per movie? So this is in a way a ratio question, but it's a very different one. So I don't even really think of it as a ratio question. This is, if we're talking about lowest cost is when you look at something called unit price. And unit price, the word unit in math means one or single. So unit price means the cost for one item. And if we can find the cost for one item, then obviously we know which one is the lowest cost. So for each of these different stores, we're going to find the unit price. And here's how you do it. For store number 1, for any store, always put dollar on top. $6 for 2 movies. And I want to know what that is for one movie. So the way we do it is we just do division. 6 divided by 2, that means it was $3 per movie. So let's look at store number 2. Again, dollars always go on top. $12 for 3 movies means that for one movie, 12 divided by 3 is $4. So this place was $4 per movie. The next place, dollars on top, $25 for 10 movies. So for one movie, in my calculator, 25 divided by 10 is $2.50. So that's $2.50, $2.50. And I'm just going to get myself a little bit of room here. And at the fourth store, $36 for 12 movies is what price for one movie? 36 divided by 12 is $3. So, which one is cheapest? Well, obviously, $3, $4, $2.50, and $3. The answer is that Movie Time is the least expensive store per movie. So no matter how many movies you get there, that's the best place to purchase movies. Okay, so unit price is an important concept. And actually, I believe we're going to do the same idea in the next question. Question 3 says, the table below shows the price per case of water at different stores. Evelyn is buying 120 bottles of water. At which price should Evelyn buy her water to pay the least? Now, it really doesn't matter how many bottles she's buying. If we can find the lowest price per unit, then we will have the lowest or the cheapest store. So let's go ahead and do exactly what we did in the last question, and then we'll talk about something else we could do in this question. So at store number 1, it was $1.75 for 8 bottles. So what is that as a cost per bottle? And again, it's just division. $1.75 divided by 8 is going to be about 22 cents. So 21875, and let me move this out of the way, sorry. 21875. So that's about 22 cents per bottle. And you don't really have to round here. So I'm not going to bother. I'm just going to leave it the way it is, but make sure you know that that's about 22 cents. The second store, $2.25 for 12 bottles. So what is the cost for one bottle? It's a division question. $2.25 divided by 12 is a little bit more, well, a bit more than 18 cents. So almost 19 cents actually. The third store, $4.59 for 20 bottles. So for one bottle, $4.59 for 20 bottles. And when I do division, I'm going to get almost 23 cents per bottle. So 2295, so almost 23 cents. And then the fourth store, it's $4.99 for 24 bottles. So for one bottle, again, it's division. So $4.99 divided by 24 gives me almost 21 cents. So 0.2079. So which one's cheapest? Well, 22 cents, 19 cents, 23, 21. Even if you don't like rounding, it's pretty clear that this store here is the only one less than 20 cents a bottle. So the cheapest one is option 2 at FoodSmart. So unit pricing is always a good method. Now, I'll just show you quickly another way you could have done this question. We know that Evelyn wants to buy 120 bottles. So instead of finding unit price for each store, what we could have done is we could have found out what she would pay if she had bought 120 bottles. So Evelyn buys at store number 1. The problem is I need to know how many packages would she have to buy. So if one package has 8 bottles, I do division, she needs to buy 15 packs to get 120. So that means I'm going to multiply the top by 15, and that would give me a total cost of $26.25 if she shopped for all 120 bottles at this store. So you could use that method, but I like the other method as well. So that's the end of video number 1. See you.